Hey friends, welcome back to the channel. The music you listen to, the things you buy, the news you read, the movies you watch, the route you take back home. This video you're watching right now, the people you date, it's your choice, no one else's. Except, no, algorithms. It's algorithms deciding for you. Those are in fact just a few things that get decided by algorithms. I could go on. Will you be selected for that job? Will the bank give you that loan? Again, algorithms. But why are algorithms so important? Is it okay to let them organize and decide our lives? But even before that, what is an algorithm? How do they work? How do you build one? Do we control algorithms, or is it them controlling us? Well, let's find out. An algorithm can mean different things to different people. I'm pretty sure that mathematicians, data scientists, and social media managers have pretty different ways of picturing algorithms in their heads. In general, today, most people associate algorithms with computers, and as we will see later, this view is actually pretty accurate. Chances are you encountered and got familiar with algorithms in a way that has nothing to do with computers though. Probably you were a small kid at school, you were attending maths, and the teacher was drawing on the blackboard. She was trying to explain how you would add two big multi-digit numbers. How would you do that? That seemed complicated. But then the teacher went through a series of simple steps, and after a few iterations, voila, magic! She computed the final number. That is precisely what an algorithm is, a series of steps that, if accurately executed and in the correct order, compute the desired output. You can think of an algorithm as a recipe. Say you want to make pizza. Even if you have never done it before, if you're given the ingredients, the tools, and an accurate list of actions you need to perform, I'm pretty sure you will be able to make a decent or at least edible pizza. In this case, ingredients are your data, you are the computer, and the recipe is your algorithm. Now, algorithms do not usually involve tomato, basil, and mozzarella. Algorithms are recipes about numbers. Unlike recipes for culinary arts, to grant accurate results, algorithms require formal and unambiguous ways to describe the operations we perform on the numbers. That is the reason why, in reality, usually algorithms look more like a long list of mathematical formulas rather than a bullet point list in a cookbook. Algorithms were known and used by ancient Babylonians and Egyptians millennia before Christ, but the word is derived from the name of a famous 9th century Persian mathematician called Muhammad al-Khwarizmi, whose name was later Latinized to algorithmi. During the Middle Ages, the word simply indicated the use of the decimal number system. It was only much later, during the 20th century, that the word started to be used in the modern sense, when mathematicians and logicians like Hilbert, Gödel, Church and Turing started to look into ways to define what is computable in an automatic way. Around 1935 and 1936, Alonzo Church and Alan Turing realized that a function is computable if and only if an algorithm exists that calculates it. And if that algorithm exists, it can be executed by a mechanical calculation device, i.e. a computer. So, put in simple terms, algorithms completely define what a computer is capable of calculating. So, now we know what an algorithm is, but why are algorithms so important? Well, it is because algorithms are the means through which we tell machines what to do. Any task that needs to be automated requires the definition of an algorithm. In the early days, computers were mostly used to accelerate the resolution of numerical problems, but as we digitalized more and more aspects of our lives, the tasks that could be delegated to computers increased dramatically. And as we hand over more and more complex tasks to computers, also algorithms become more complex. As we said, if you need to instruct a computer to perform a task, you need to define an algorithm. That is, you need to explicitly tell it what are the steps it needs to go through. But when a task becomes complex, it is not very easy to define what are the steps required. Say you want to define an algorithm that computes whether a number is even or odd. That's pretty easy, right? You just divide that number by 2. If the result is an integer, then it's even, else it's odd. Simple. But what if you want to define an algorithm that, given a picture of a person, tells you whether the person is happy or sad? Seems easy, right? Humans are pretty good at this. But how would you define an algorithm that determines if someone is happy? What steps will it include? Is the person smiling? How do you know if a person is smiling? Is her showing her teeth? Can a person be happy without showing their teeth? Well, I guess so. How about this picture? She's showing her teeth, but she doesn't seem happy at all to me. So actually, it is not as easy as it might seem. Let's make another example. Say that I want to define an algorithm that, given a song, tells whether I'd like it or not. In my case, it is pretty straightforward. Is it a Pink Floyd song? If yes, I'll definitely like it. Otherwise, the answer is no. Now, what about normal people? Say you are into rock music. There is a good chance that you like a song with distorted guitar in it. Now, metal also often features distorted guitars, but you absolutely hate metal. Or you might like acoustic versions of rock songs which have no electric guitars in them. As you can see, it's not easy to capture all the features that make a song likable to you. So, how does Spotify know what song to suggest you next? In this case, instead of explicitly defining an algorithm for that specific task, they apply algorithms that are capable of inferring models and automatically improve by the use of data. So no need to tell the machine the single steps it needs to go through. It will figure it out directly from the data. This is usually done leveraging on a mathematical optimization and statistical computing. You might have heard about these kind of algorithms. It's those that are used in machine learning. That is great! I couldn't be bothered telling machines how to do stuff. Let's just have them figure it all out on their own. We have much better things to do with our time. And that is precisely what we're doing, and it's going great. Absolutely flawless. Yep. Letting algorithms blindly ruling our lives can be problematic and in some cases even dangerous. So what is the takeaway? Well, simple. Algorithms are evil. We should reject all technology and move to a remote cabin in the woods. End of the story. Or, second best option is to ensure that we have regulations, standards, certifications and laws in place that can be applied to algorithms to ensure that they are validated, safe and unbiased. There is a countless number of certifications and standards that apply to everything we build and use. Our phones, computers, domestic appliances, cars, trains, planes, building bridges, but unfortunately there is no such kind of well-established set of rules and regulations that apply to algorithms. Well, I think it's about time that we fix that. Only this way we can be sure that it is us controlling algorithms and not the other way around. What do you think? That is all for now. I'm Francesco Fusco and this is Decode, the only place in the world where we take reality and decode it for you so you don't have to do it on your own. If you liked today's video, consider subscribing. Thank you so much for watching. See you guys in the next one. Goodbye.